Alrighty, so chapter 5.8, we're going to briefly discuss how we find molecular formulas. I won't use the term molecular formula or not molecular formula. I won't use the term molecular weight too often. I will typically use the term molar mass, which we get to in the next couple sections. But to find the molar mass, we first need to start with the molecular weight of the compound. That helps us figure it out. So our molecular formulas that we learned for our covalent compounds tells us the amount of each element present in one molecule of the compound. For example, we look at water. Our formula tells us with this little subscript that there are 2 hydrogen atoms in one molecule of water. And there's no subscript on the oxygen, so there's 1 oxygen atom in one molecule of water. So that's how we read our molecular formula. And then we can use the molecular formula to calculate the molecular weight, which is the mass of one molecule of the compound. Sometimes called molecular mass, but I like molecular weight better. They're pretty interchangeable. So 1 molecule of water, like I said, 2 hydrogen atoms, 1 oxygen atom. So the mass of 1 molecule of water, the molecular weight of water is equal to the mass of 2 hydrogen atoms plus the mass of 1 oxygen atom. So it's additive. We take the masses of those atoms and combine them when we combine the atoms themselves into the molecule. So the molecular weight of water is equal to 2 times the atomic mass of hydrogen plus the atomic mass of oxygen, because there's only 1. So 2 times 1.008 AMUs. So remember AMUs, those are our atomic mass units. Basically the mass of a neutron, proton, neutron. And then 16 AMUs for oxygen, and we end up with 18.02 AMUs as the molecular weight for water. All right, cool. So we can do the same thing with ionic compounds, but remember ionic compounds we always write as the empirical formula because the actual compound is typically made up of this big lattice. Remember, I'm going to try to draw it again. This time they're going to be the same size because that's the way that I started drawing it now. So remember, our ionic compound is usually made of this big old lattice full of ions. So we don't use the molecular formula because it would probably have like tons and tons of atoms in it. But the empirical formula is the simplest whole number ratio, like NaCl. We have 1 sodium atom for every 1 chlorine atom in the molecule. So 1 sodium ion, 1 chloride ion in our molecule. And then we use this to calculate the formula weight. So we call this a little bit of a different thing. We had molecular formulas and molecular weights. Now we have empirical formulas and formula weights for ionic compounds, but they're the same thing, just called a little different because now we're using empirical formulas instead of molecular formulas. If you remember, for covalent compounds, empirical formulas and molecular formulas are different. So we want to always use molecular formulas and molecular weights with covalent compounds, and we want to use empirical formulas and formula weights with ionic compounds, but it's the same process. 1 molecule of sodium chloride has 1 sodium atom and 1 chlorine atom, also known as 1 sodium ion and 1 chloride ion. So the mass of 1 molecule of sodium chloride is, or the formula weight of sodium chloride, is the mass of 1 sodium atom plus the mass of 1 chlorine atom. Chloride ion, same difference. The mass doesn't change very much at all when you take away 1 electron or add 1 electron. Anywho, the formula weight is equal to the atomic mass of sodium plus the atomic mass of chlorine, because we only have one of each. So 22.99 AMUs plus 35.45 AMUs. Our formula weight of sodium chloride is 58.44 atomic mass units. Cool. All right, let's practice a little bit. So we want to calculate the molecular weight of caffeine. All of us love caffeine, I'm sure. Not good for us, but it's what keeps us going, especially me. I'm sure you've seen me drink coffee multiple times during our classes. But here is caffeine. This is the molecule itself. This is our molecular, our model. This is our molecular model. If you remember, the black atoms are carbon. So we've got 1, 2, 3, 4, 5, 6, 7, 8. So we've got 8, right? Did I miss any? 1, 2, 3, 4, 5, 6, 7, 8 carbons. We've got 2 oxygens, 1, 2 red ones. We've got 1, 2, 3, 4 nitrogens. Those are the blue ones. And hydrogens. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got 10 hydrogens. Hopefully I counted all of those right. If not, feel free to correct me in class. Alrighty, so to calculate the molecular weights, we want to know, this is how many atoms of each type are in our molecule. So this is 1 molecule of caffeine. So to calculate the molecular weight, we just want to use these numbers. We don't even have to write the molecular formula. We can if we want. It'd be C8, H10. We usually put C first and then H, just how it works. And then 4 and 4, O2. So there we go. That's our molecular formula, though we don't really need it because this is what we really want. So to add it all together, we want 8 times the the atomic weight of carbon, which is 12 AMUs. And then we want 2 times oxygen, which is 16.00 AMUs. Carbon might be 12.01, but I'm just going to do 12.00 here. Nitrogen is 14. I'm just going to call it 14. It's probably 14.01 or something, but I'm going to call it 14 right now because I don't feel like looking it up. And hydrogen was 10 times 1 point, I'm just going to do 1.01 AMUs because I know that one is 1.01 or 1.008 as it said on the previous slides, but I'm going to round it. All right, so we multiply those and then add it all together. So if I take my calculator and I do parentheses 8 times 12, parentheses plus, parentheses 2 times 16, parentheses plus, parentheses 4 times 14, parentheses plus 10 times 1.01, parentheses. So that adds up to 194.1 AMUs. All right, so that's how you find the molecular weight of a molecule given a molecular model of the molecule. So there we go. We combined a few different things here. We combined how to find the molecular formula from a picture and how to calculate the molecular weight from that molecular formula / picture. So that's it for tonight. So I'll see you guys tomorrow.